This video showcases the environment design, concept development, level building, and overall world building within Unity for our stealth survival horror demo. A few of them. Given the scope of the project and the small size of our team, we each had to wear multiple hats. Tasks and roles were divided among us, sometimes assigned, sometimes self-selected. I chose to take on the responsibility of crafting the technical and aesthetic bits of the levels for the game. I primarily focused on level design and writing the narrative, with some contributions to world building as well. On the side, I also assisted with the asset production pipeline and playtesting. One of the earliest decisions we made was about the level structure. We settled on two levels, the first designed to introduce the basic mechanics, and the second to really reinforce the game's survival horror identity. In other words, the first level guides the player through exploration and item collection. The second, it throws them into an open environment where the goal is simple: run, survive, and find safety, while being chased. By week 4, I started diving into pre-production and testing, just before jumping into blockouts and scene building. I used my MacBook as the benchmark for the lowest specs the game should be able to run on. To make an informed choice about visual performance, I explored Unity's different rendering pipelines: the standard render pipeline, universal render pipeline, and high-definition render pipeline. In the end, I chose the universal render pipeline. It was optimized for lower-end machines, gave us the semi-realistic visual style we were aiming for, and didn't overburden the hardware we were developing on. URP also offered impressive customizability, from render passes to post-processing, and the ability to access source code for micro-optimizations down the line. Between weeks 4 and 5, we hit our first real hurdle. We had no concept art. So, as the writer, I took the initiative and made a decision about the level design. I came up with a rough concept for the levels and built a basic layout, guided by the story outline I'd already created. At that stage, I only modeled the exterior, nothing more. As time passed and we still didn't have solid concepts, I decided to take things a step further. I recreated my own house as a full environment, but in a different 3D software, not Unity. I made that choice deliberately because finalizing concepts wasn't technically my role, and I didn't want it to feel like a full commitment. The goal was simple: to better understand the tone and atmosphere of the game, and to use the blockout as a reference moving forward. I also spent some time fixing parts of the house model since certain mesh faces had backface culling enabled. I searched online for a solution, but nothing seemed to work. Eventually, after some experimenting in Blender, I discovered the issue was with the normals of the faces. So instead of trying to fix it in Unity, I went back into the original asset pack in Blender, where I had modeled the house, and corrected the normals there. We also ran into another challenge. Each of us had been building and testing mechanics, animations, and levels in different versions of Unity. That quickly became a problem. So we sat down as a team and decided to lock in a specific Unity version. We started with 2022.347 F1 and eventually settled on 2022.360 F1. As the level designer, I sat down and mapped what I would like the player to do and constructed some basic objectives. I sat down with the primary asset developer and discussed my vision for the player's journey through the house. I wanted them to explore the bottom floor first, and because the house was a bit messy, the player would need to push an object out of the way to reveal a path leading upstairs. This would encourage them to fully explore the floor before progressing. However, the push mechanic wasn't implemented in the prototype, as the programmer had to shift focus and take over some UI design tasks. So, to work around this, I talked with the programmer, and together we came up with a solution. We implemented text objective cues and visual markers like glowing indicators to guide the player through the experience. Once most of the assets were in place, I turned my attention to lighting. By default, the game was brightly lit, but it lacked the atmosphere and mood we were aiming for. The scenes felt too bright and empty. To address this, I started by changing the skybox and adjusting global illumination. I also added fog and switched to real-time lighting, since baking wasn't working properly due to UV overlapping. The issue with baking was that it messed with the textures, causing them to either become too dark or pitch black. It also resulted in strange shadows and highlights that didn't make any sense. I tried to fix this by increasing the light map padding, but that only raised the specifications needed for the PC. Ultimately, I decided to switch to real-time lighting, which gave much cleaner results both indoors and outdoors. The issues with light baking stemmed from the limitations of the machine we were building the game on. With version 5 and version 4 of the game combined, we created version 6, within which I tested some of the core mechanics. By this point, the general look and feel of the game were starting to take shape. The lighting was working well, casting the right mood, and the fog added to the gloomy atmosphere. The objective markers, which we created using the visual effects graph, were now clearly guiding the player, showing them exactly what to do and where to go. Some of our successful player mechanics included idle, walk, run, jump, crouch, opening doors, picking up items, and healing. As for the environmental mechanics, we had nav-meshed antagonists with cycling animations, driven by the finite state machine. Plus, we had falling tree leaf particles, and of course the fog, which really helped set the tone. The footage you're seeing now was captured on the MacBook Air M1 2020,